Assalamualaikum to our lecturer and friends. So today we from group 7 we present our lab experiment 4, which is minor losses in pipe. Next. Next. So for the first one is objective. Our objective for this lab is to determine the loss coefficient, KL value, and minor head loss, HLM, in pipe components or fittings for different water flow rates, pipe diameter, and pipe bands. Next is theory. I will pass to Nasrin Aina.
Okay, for the theory part in the experiment. Okay, the flow in piping system at different flow rates is may require to pass through a variety of fittings, bend or abrupt changes in area. Additional head loss, called as minor head losses (HLM), are accounted in this experiment, primarily as a result of flow separation. By simplifying the Bernoulli equation between 2 points for the horizontal pipe, the pressure loss, or known as P, and total head loss, HLT, could be determined as this equation. Okay, next slide. Okay, based on this equation, we can see that P1 minus P2 is the pressure drop between 2 points in Pascal unit, rho as density of flowing medium, G as gravity constant 9.81, V1 minus V2 is changes of velocity of flowing medium from point 1 to point 2. HLT is the total head loss, HL is the major losses, F is the coefficient of pipe frictions, which is dimensionless. L is the length of pipe in meter. Di for internal diameter. V for HL is the speed of flowing medium for tested pipe. HLM as minor head loss. V for HLM is the speed of the flowing medium. Okay. The value of KL is strongly dependent on the geometry of the component considered, as well as the fluid properties, includes the Reynolds number, and the mathematical function of them can be expressed as the equation below. KL equal to geometry Reynolds number. Okay. In many practical applications, the Reynolds number is actually larger enough so that the flow through the component is dominated by the inertia effects, leaving the viscous effect as secondary importance in a flow which dominated by inertia effects. It is usually found that pressure drop and head losses correlated directly with the dynamic pressure. Therefore, the friction factor F for very larger Reynolds number in fully developed pipe flow is independent of the Reynolds number. The same condition is found to be true for flow through pipe components and fitting. Thus, in most practical cases, KL for every component are function for geometrical only. In this experiment, the KL value and HLM in pipes for different water flow rates, pipe diameters, and pipe bands will be determined. The description related to each the tested geometry is as follow. Next slide. Okay, the sudden expansion or enlargement or sudden contraction of flowmetry. KL for sudden expansion and enlargement in circular ducts are shown in figure 2. Okay. Okay. The value of KL in this for the fluid flows through a sudden expansion or enlargement, or also known as contraction, can be obtained by considering the equation 7, A1 equal to V2, A1 V1 equal to A2 V2, momentum equation 8, and energy equation between point 1 and point 2 for the control volume. Okay, next.
Okay, so next we go sit with apparatus and procedure. Next. Okay. Apparatus being used is pressure measurement test bench, which has inlet valve, two tube manometer tube, tested pipe section, and outlet valve. Next. And then we're going to proceed with procedures. which is first, we need to determine the direction of water inflow and outflow for the tested pipe section. Next, we need to fully open the inlet valve of tested pipe section and close the inlet valve for non-tested pipe section. And then we need to turn on the pump slowly and slowly open the outlet valve by turning it into anti-clockwise direction until it fully open and wait for a while in order to remove any air bubbles for the. Then we need to connect the manometer tubes from we need to connect the manometer tube from those H1 and H2 of the tested pipe section to the two tube manometer, which is H1 inlet and H2 outlet. Next, record the value of H1 and H2 in millimeter at two tube manometer. Record the values of H1 and H2 at two tube manometer. Aku ulang. Next, we need to determine the actual water flow rate, which is Qx, by recording the time taken to collect the 3 liters volume of water at the tank. We need to reduce the opening of outlet valve and repeat steps. Step 5 and 6 for 5 different value of Qx. After finish, remove the manometer tube first to avoid the bubbles in tube. And lastly, with pump in running condition, repeat step 1 until step 7 for the other tested pipe section. After finish, remove all the manometer tubes from the system, fully close the inlet and outlet valve and turn off the pump and the main switch. That's all for procedure. Next, I will pass to next member.
Okay, I will present result and data analysis. So this is table 1, showing the data for sudden enlargement and sudden contraction. So in this experiment, we get the volume of water collected is 3 liters. So we need to record the time in second and also H1 and H2 in mm. So we need to determine the Q actual and also the data H. So to determine Q actual, we use this formula, which is volume of water collected divided by time. So we must make sure the unit for Q actual adalah Q actual is liter per minute. So here time in seconds, so we need to convert it. So next is data H. Data H is H1 equal to H2, where data H in meters. So from the experiment, the unit is in mm, so we need to convert it to meter. So next is table 2, shown the data for elbows and pipe bends, which 90-degree angle, 90-degree bend, and 45-degree angle. So the volume of water collected for this data is 2 liter. Okay. Next is table 3, which is data for pipe branches, Y type and also T type. The volume of water collected is 3 liter. How to determine Q actual and data H is same goes with the explanation. So after that, this all data from table 1, table 2, and table 3 will use in this equation to determine the total heat loss. Okay, next I will pass to Al-Azim.
Okay, so I will explain about discussion. Okay, next. So in this discussion, we have 3 questions. The first one, we need to calculate the minor losses. Loss coefficient is KL and HL for each pipe. Then we need to calculate the coefficient of friction, which is F, using the Blasius formula. So for the first pipe, which is a sudden enlargement, First one, we need to calculate the V, which is velocity from the flow rate inside the pipe, and then we need to find the KL with a loss coefficient using the formula 1 minus A2 minus the formula is 1 minus A1 over A2 squared. So from the formula we get the value of 0.4 for the loss coefficient, and then we substitute it in HLM formula for get the HLM to get the minor head losses for the pipe. Okay, next we move to the second pipe, which is sudden contraction. So from the sudden contraction, the first diameter we get is 0.02, and the second diameter, which is 0.017. And the Q average we get from the flow rate in the pipe, which is 0.0233 meter cube over minute. And then from the information we get, we substitute in the V to get a V, which is 37.83 meter per minute. And then we calculate the head losses, we get 0.4, and the minor head losses, we get 0.0081 meters. And then we go for the Reynolds number. We get the 24,853. We substitute it in the F formula, which is the coefficient of friction. And then lastly, we get submit the information in the Blasius formula to get the into the HL formula, major losses. It's same for the 2 times 90 angle pipe, but the difference is to find the KL value. For the 2 times 90 angle pipe, we need just to sum it 1.5 plus 1.5, we get a 3 for the loss coefficient. Then the same formula, we can get the HLM, Reynolds number, coefficient of friction, and major losses. Okay, next. So 2 times 90 bend pipe and 2 times 45 angle pipe. So basically, it's the same. With the same method. The KL we need to plus 0.7, 0.7, and 0.4, 0 plus 0.4. That's it for the bend pipe, angle pipe. Okay, next. Okay, move to the branches. So in the branches, we get 2 types of it, which is Y and T type. Okay, first one, T type. We need to calculate the first, the velocity is 82.5818 meter per minute, and then the KL we need to find it in the table given in the lab manual. Okay, and then we need to calculate the HLM, the number, after that the coefficient friction, and then the major losses. The same is the T type is same with the Y type. We the same method. We just submit the information from each pipe. Okay, next. Okay, the second question is discuss effect the different water flow rate, pipe diameter, and pipe bends on the value of loss coefficient KL. So flow rate. First one, which is flow rate. So how the flow rate affect the minor head losses. So when the flow rate is higher, they with high values, then they are more friction will contain in the pipe. So we can get the higher loss coefficient in the pipe. Second one is diameter. When the smaller diameter, then there are more friction it will contain and energy will loss. Thus the higher the loss coefficient we get. Okay, the last one is pipe bends. Pipe bend will affect the loss coefficient. So the bending of the pipe, the more the gradual turn if the bend, so we get the lower loss coefficient for the pipe instead. Okay, we move to the last question. Next. So the last question we need to briefly discuss on factor contributing to error and or inaccuracy in experiment data, and the possible combination to improve the existing result. So first one, we will discuss about the errors. The first error we get from the experiment basically is present of air bubble in the tube as well as in the water, in the pipe. So the second one is parallel error due to the incorrect position of eye to the scale when we're reading the info from the pipe or from the meniscus. Okay, the last one is water level into tube manometer cannot be calibrated if fluctuate heavily. So the recommend for me is make sure no air bubble trapped in the tube or pipe before the experiment, and make sure position of the eye is perpendicular to the readings to the meniscus, and adjust the volumetric flow until it do not fluctuate or take the average reading for every experiment. Okay. Next one, I will pass to the conclusion.
Next slide. So in this experiment, the objectives to determine the loss coefficient, KL value, and the minor head loss, HLM, in pipe components and fitting for different water flow rates, pipe diameters, and pipe bends. And these are all based on the data collected from this experiment. For bends, the lower the K value, the smoother it is, and the opposite for a high K value bend. In conclusion, the minor head loss varies with different size and angle of pipe. Thank you.